The double angle identity for sine says that if you have the sine of 2 theta, that equals 2 times the sine of theta cosine theta. For cosine of 2 theta, you could use cosine squared of theta minus sine squared of theta, or by rewriting using Pythagorean identities, you could get the 2 alternate versions of 1 minus 2 sine squared of theta, or 2 cosine squared theta minus 1. The tangent of 2 theta equals 2 times the tangent of theta over 1 minus tangent squared of theta. For practice in using our double angle identities, we are going to look at example 7, where we are told that the cosine of theta equals 3/5, and that the sine of theta is less than 0. And then we are asked to find sine, cosine, and tangent of 2 theta. When you have a problem like this, the first thing that you must look at is the given information. We are told about the cosine, and we are told that it is positive 3/5. We have to think about, where is cosine positive? Cosine is positive in quadrant 1 and quadrant 4. We are further told that the sine is less than 0, which means that the sine is negative. So we have to think about, where is the sine negative? That is in quadrant 3 and quadrant 4. Where do these things both happen? Quadrant 4 is where they both happen. So we are going to set up a figure with angle theta in quadrant 4. And the cosine x over r has to be 3/5. Well, we've used this a lot now, and we know that if we have 3 on one leg, the other leg has to be 4 if the hypotenuse is 5. But remember, when you are in quadrant 4, that your y value must be negative. Now that we have our figure set up, we are going to use our formulas. The sine of 2 theta equals 2 sine of theta cosine theta. So we're going to keep the 2 on the front. Now we're going to look at this angle theta that we just created. The sine of this angle theta would be negative 4/5. The cosine of this angle theta is 3/5. If we multiply 2 times negative 4/5 times 3/5, we get negative 24 over 25. For the cosine of 2 theta. We were told about the cosine of theta, so I'm going to use that version of the formula, which is 2 cosine squared theta minus 1. So we would have 2, our cosine, we were told, was 3/5. We're going to square that, subtract 1. So we're going to have 2 times 9 over 25 minus 1. This will give us 18 over 25 minus 25 over 25, which gives us negative 7 over 25. Our last item is to do the tangent of 2 theta. The formula for tangent is 2 times the tangent of theta over 1 minus tangent squared of theta. So our numerator will be 2 times the tangent of our theta is going to be -4/3 over 1 minus -4/3 that we are squaring. So our numerator becomes -8/3. On our denominator, we will have 1 minus 16/9. So we're going to think of that as being -8/3 over 9/9 minus 16/9. So we are now going to have -8/3 over -7/9. Rules for fractions say that you multiply by the reciprocal of the denominator. So we are going to take -8/3 times -9/7. You would get positive 72/21. Simplify that, you're going to get 24/7. On example 8, you are asked to simplify the expression using a double angle identity. And then on problem A, we are given 1 minus 2 sine squared of pi/9. What you need to recognize on this one is that this is one of the versions of the cosine of 2 theta. So we are going to rewrite this then as the cosine of 2 times the theta, which is what comes after the function. In this case, it's pi/9. Now do your multiplication there, and you get the cosine of 2 pi/9, and that's all you need to do with this. You are done with that problem. On example B, we are given the expression 2 times the tangent of 50 degrees over 1 minus tangent squared of 50 degrees. As soon as I see tangent in this expression, I know that this one is the tangent of 2 theta. Our theta is whatever the argument of tangent is. So this is going to be the tangent of 2 times the 50 degrees, which is going to give us the tangent of 100 degrees. That's all you need to do. You are done. Stop there. Half angle identities are used when the angle measure that you are given is not on the unit circle, but it is half the measure of an angle that is on the unit circle. For the sine of theta over 2, the formula is plus or minus the square root of 1 minus cosine theta over 2. The plus or minus out front means that you must determine before you even start whether the sine value for that angle will be positive or negative, and this is based on what quadrant the given angle lies in. Cosine theta over 2, notice, is very, very similar. You have to determine whether it's positive or negative. And then inside the square root, you have 1 plus cosine instead of 1 minus cosine in the numerator over 2. When you are doing the tangent of an angle, you have 3 choices for which formula you want to use. The first formula, plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta, is actually the most complicated of the 3. If you choose to use this one, you must determine before you begin using it whether the tangent for that angle will be positive or negative. Again, this is determined by which quadrant the original angle measure falls in. The other 2 versions of the formula look very different, and they are not inside square roots, which makes it nice. Notice that on the other 2 versions, there are no plus or minus out front. You do not have to use the plus or minus. Personally, I use either one of the second or third formulas anytime I need to do a tangent, because I don't have to think about that plus or minus and potentially make a mistake by forgetting it. The first example we are going to do is we need to find the tangent of 7 pi over 8. 7 pi over 8 is not on our unit circle. But if we do a little bit of algebra, we can find an angle measure on the unit circle, and 7 pi over 8 is half of that angle measure. To help us figure out what that is, we're going to do a little bit of algebra. What we're going to do is set up an equation where theta over 2 equals the angle measure that we are given, 7 pi over 8. We need to solve this equation for theta, because in our formulas, what is required of us is theta. In order to do this, we're going to multiply both sides by 2, and this will now give us theta equals 14 pi over 8, but that simplifies if you divide both numbers by 2 to equal 7 pi over 4. 7 pi over 4 is a number on our unit circle, and so that's what we are going to use in our formula as theta. I'm going to, as my first example, use the second version of the formula, sine theta over 1 plus cosine theta. So what we are figuring out is that the tangent of 7 pi over 8 equals the sine of what we found theta to be, which was 7 pi over 4, and that goes over 1 plus the cosine of 7 pi over 4. Now we're going to go to our unit circle and substitute in what we know about the sine and cosine of 7 pi over 4. This means that our numerator will become negative square root of 2 over 2. All that goes over 1 plus, and then the cosine of 7 pi over 4 is positive square root of 2 over 2. We can't simplify this complex fraction until we have one term over one term. And right now, our denominator is 2 terms. We need to get a common denominator for 1 and the square root of 2 over 2. Well, we can write 1 as 2 over 2. So the next thing we're going to do is leave the numerator alone and then rewrite the bottom as 2 over 2 plus the square root of 2 over 2. Now that we have a common denominator, we can actually add those fractions. So our numerator is our negative square root of 2 over 2. Our denominator becomes 2 plus square root of 2 over 2. When you have complex fractions where you have a fraction over a fraction, remember that the rules tell us for fractions that we leave the numerator alone and we multiply by the reciprocal of the denominator. Well, now, if you look at this, we have a 2 in the numerator and a 2 in the denominator. 2 over 2 equals 1. If you multiply what's left, you'll have negative square root of 2 over 2 plus the square root of 2. That is the answer. You do not need to do anything else to this. Before we go on to another example, I want to go back and look at those last 3 steps for just a moment. Remember that we had at one point negative square root of 2 over 2 over 2 plus square root of 2 over 2. And then we multiplied by the reciprocal, and those 2's wound up canceling each other out. So what that means is you don't have to take the time of doing the step of multiplying the reciprocal every time when these denominators are exactly the same. When you have a 2 here and a 2 here, those are always going to cancel. So we can go ahead and just cancel the 2's at that step, and what's left is what our final answer was, the negative square root of 2 over 2 plus square root of 2. This will just save you a little time as you go forward on these problems. I'm going to go ahead and show you how to use the other 2 versions of the tangent formula for that same problem of the tangent of 7 pi over 8. In using that version where it's the square root of 1 minus cosine theta over 1 plus cosine theta, out front, the first thing we have is that plus or minus. This means we have to ask ourselves about that angle that we are finding the tangent for. We are finding the tangent for 7 pi over 8. Where is 7 pi over 8 located? It is located in quadrant 2. If the angle is located in quadrant 2, now we need to decide what kind of sign would the tangent have. We know that the tangent is negative. Remember that in our first version of this problem, we found that theta was 7 pi over 4. So that's what we're going to put into our formula. Because it's negative, we have to put the negative sign out front. And then we'll have a square root of 1 minus the cosine of 7 pi over 4 over 1 plus the cosine of 7 pi over 4. So, substituting what we know, cosine of 7 pi over 4 to equal, we're going to have 1 minus the square root of 2 over 2 over 1 plus square root of 2 over 2. And all of that is inside the radical with a negative sign out front. This time we have 2 terms in both the numerator and the denominator, so we have to get common denominators to write them as single terms. Keep that negative sign. Common denominator, when your denominator is 2, will be 2. So we're going to write 1 as 2 over 2 minus the square root of 2 over 2. Put that over 2 over 2 plus the square root of 2 over 2. Now that we have common denominators, we can actually subtract the fractions in the numerator and add the fractions in the denominator. The numerator inside our square root will become 2 minus the square root of 2 over 2. The denominator will become 2 plus square root of 2 over a 2. And all of that's inside your square root symbol. Here again, we have a complex fraction where the denominators are exactly the same. So we can just save that step of multiplying by the reciprocal and cancel right here. And we wind up with a final answer of negative square root of numerator 2 minus the square root of 2 over denominator 2 plus square root of 2. This answer looks very different from the first answer, but if you actually plugged it into your calculator, you would get the same decimal value. You will not be asked to simplify this any farther, so you could leave your answer like this. For the third version of the tangent of theta over 2, we're going to use 1 minus cosine theta over sine theta. On this version, there is no plus or minus, so we don't have to worry about that. The only thing we have to think about is that we already said that theta is going to be 7 pi over 4. So using this version of the formula, we will be finding that the tangent of 7 pi over 8 equals 1 minus the cosine of 7 pi over 4 over the sine of 7 pi over 4. We're going to use our unit circle and find our values for cosine and sine of 7 pi over 4. So we're going to have 1 minus the cosine of 7 pi over 4 is positive square root of 2 over the sine of 7 pi over 4 is negative square root of 2 over 2. At this point, we have that same situation where we need to get common denominator with the two terms in the numerator. So we're going to have 2 over 2 minus the square root of 2 over 2. All of that over negative square root of 2 over 2. Rewrite your numerator as one fraction, so we will have 2 minus the square root of 2 over 2 over negative square root of 2 over 2. We have a complex fraction with common denominators, so we're going to cancel those denominators altogether. And our final answer for this version of the formula will be 2 minus the square root of 2 over negative square root of 2. Again, it doesn't look the same as the first two versions, and it's because we can rationalize and make them look like the other versions. It does give you the same decimal value. You do not have to do anything, just leave your answer alone. You are done. On our next example, we want to find the cosine of 165 degrees. Because we want to use a half angle formula, that means that the version we want is the cosine of theta over 2 equals plus or minus the square root of 1 plus cosine theta over 2. Notice there's a plus or minus out front. That means that the first thing we're going to have to do is think about what quadrant does 165 degrees fall in? Well, that falls in quadrant 2. Now ask yourself, if you're in quadrant 2, is cosine positive or negative? It's negative. So when we start this formula, the first thing we're going to have to do is put a negative sign out front. The next thing we have to do is figure out what theta should be. We're using this formula because 165 degrees is half of a number that is on the unit circle. 165 itself is not. We're going to go back to the idea of setting up that little equation where we do theta over 2 equals 165. To solve this, we need to multiply both sides by 2. If we do this, we get theta equals 330. 330 is an angle measure that's on the unit circle. So that's what we're going to use in our formula. This means now that we are finding that the cosine of 165 degrees is, remember we said it needs to be negative, square root of 1 plus the cosine, and we just said theta is 330, and all that goes over a 2. Now we're going to substitute what we know about the cosine of 330 from the unit circle, and we know that that equals the square root of 3 over 2. So our numerator becomes 1 plus the square root of 3 over 2, and all of that is over a 2. Just like we were doing in our tangent formula examples, we need to get a common denominator for the two terms in the numerator. So we will rewrite 1 as 2 over 2 plus the square root of 3 over 2 over a 2. Now we can make that numerator into one fraction. So we will have 2 plus the square root of 3 over 2, and all that is over a 2. We still have complex fractions like we did earlier. So this will be the same thing as if we had 2 plus the square root of 3 over 2. Now, instead of writing divided by 2, I'm going to write times 1/2, because remember, dividing by 2 and multiplying by 1/2 are the same thing. This now gives us negative square root. Now we're going to multiply those two fractions. 2 plus the square root of 3 times 1 equals 2 plus the square root of 3. On the bottom, 2 times 2 equals 4. What you may not remember if you haven't done it for a little while is that when you have a fraction inside a square root, you can separate it into a fraction containing two separate square roots. This is a square root property. Well, that numerator is a mess, and we can't do anything to make that any easier. When you have a square root inside a square root, you don't want to mess with that. So that numerator is going to stay 2 plus the square root of 3 inside a square root. But we know that the square root of 4 equals 2. This is your simplified answer, and this is the way that you would leave it. Our final example for half-angle identities asks us to find the sine of 15 degrees. Again, 15 degrees is not on the unit circle, but it is half of an angle that is on the unit circle. Because it's a sine function, we want to use the sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 2. Because the plus and minus is out front, we have to determine, first of all, should we use a positive or should we use the negative? 15 degrees is in quadrant 1. Everything in quadrant 1 is positive, so the sine is positive. Next thing we want to do is find what theta should be. So we're going to set up our little equation of theta over 2 equals 15. Multiply both sides by 2, and we get theta equals 30. That's a nice easy number, and you may well have been able to do that in your head, but that's always the process that you're going to use when you want to find what angle measure should I use in the formula. So now what we are finding is that the sine of 15 equals, and since it's positive, we use the positive version, 1 minus the cosine, we just said theta is 30 over 2. Because it's positive, I don't need to continue to write that positive sign. I just wrote it that first time as a reminder. So we're going to have the square root of 1 minus the cosine of 30 is the square root of 3 over 2, and then that all goes over a 2. So you're going to find that there's a lot of repetitiveness in these answers, a lot of similarities. So we now have, let's get common denominators for the two terms in the numerator, 2 over 2 minus the square root of 3 over 2. All of that is over a 2. So we have 2 minus the square root of 3 over 2 divided by 2. But that means that we have the square root of 2 minus the square root of 3 over 2 times 1/2, which gives us the square root of 2 minus the square root of 3 over 4. We can't simplify the numerator, so we're going to leave it as the square root of 2 minus the square root of 3 over the square root of 4 is 2. And that's your final answer. You do not need to do anything else.